Dear learner, I welcome you all to the program Postgraduate Certificate in Industrial Safety. I am Dr. Sanjay Agrawal, program coordinator of this program, and I am also working as associate professor in electrical engineering in School of Engineering and Technology, Indira Gandhi National Open University, New Delhi. In this session, we will discuss electrical fire controls and prevention, working at height, permit to work, that is for ensuring safe and efficient work management, and working at high voltage, and what are the different related hazards with the high voltage, which comes under the topic electrical safety, fire and its prevention. So first of all, we are going to discuss electrical fire controls and prevention. Electrical malfunctions are the third most common cause of the residential building fire, representing about 6% of all home fires. Fortunately, home electrical fires can be preventable. This is considerable that before each project begins, the project manager or designee will contact with the local fire department and determine whether any variation from the company's standard fire prevention procedure are required or not. Just being aware of the dangerous and potential causes of the electrical fire will help you learn how to avoid them. So one by one we will discuss. First we will discuss what is the effect of the loose outlet. So what is the electrical fire risk due to this loose outlet? If you plug a cord into an outlet with no resistance at all, or the cord easily falls out, the outlet is fire hazard. Loose connection cause the outlet to generate more heat than it is designed to, which could start a fire. Now, what are the fire prevention technique due to this loose outlet? What you have to do? Repair or replace loose outlet as soon as you notice them. You may be able to tighten the wire, nuts to improve the connection, or you may need to replace the outlet. Second point that we are going to discuss, that is a old light fixture. What are the electrical fire risks associated with the old light fixture? Every year the light fixture in your home or industry degrade the little more. A fixture may last 25 or even 50 years, but eventually the wire insulation becomes burned or blackened. Connection corrode and bulbs do not fit well in the socket. Continuing to operate light fixture with this problem could present a fire hazard. Now, how this prevention technique can be used? If your light flicker or would not say lit and you have ruled out light switch problem, replace this fixture as soon as possible. Also be careful not to overload light fixture. For instance, never use 100-watt bulb in a fixture rated for a 40-watt. However, 100-watt equivalent CFL is acceptable because it produces the same light level but not nearly as much as heat as 100-watt bulb. Now we have to see the effect of the extension cord. So again here there are electrical fire risks are associated in the extension cord. Misusing extension cord is a common cause of residential fire. Kinked or smashed cord produce more heat, eventually melting the insulation from the inside out. Plugging a heat producing appliances like heater, motor, conditioner, etc. into an extension cord can cause overheating, and due to this overheating fire may take place. So for the fire prevention technique, what you have to do? Choose heavy duty extension cord for the every application. Lay the cord out of the way where no one will step on it. Do not run cord under the floor rugs which could generate excessive heat. Never permanently rely on the extension cord. If you do not have enough outlet, have an appropriate electrician install as required. Now we have to see the effect of limited electrical power and circuit. So what are the electrical fire risks if you have a limited electrical power? In some homes, there simply is not enough power available or individual circuit to handle electrical demand. Every time a breaker trips, the circuit has overloaded. Older homes are especially prone to this problem because they were not designed with today's high electrical demand in mind. Tripped circuit breaker gradually become so damaged that they no longer work properly. Excessive heat can melt wiring insulation and expose wire, creating a recipe for disaster. Fire prevention technique. If the kitchen or bathroom circuit breaker trip constantly, so do not simply reset the breaker and do it all over again and again. Instead, hire an electrician to install additional circuit and protect your home from the electrical fire. Now we have to see the effect of the defective appliances or the damaged cord. Because due to these defective appliances or damaged cord, again fire may occur. In individual electrical devices can malfunction and draw more current than they should without tripping a breaker. This creates excessive heat and can melt wiring insulation. If wiring is exposed for any reason, it can cause a fire hazard. So what you have to do to avoid this type of fire? You have to pay the attention to your appliances, check cords for excessive heat or exposed wire. If a device makes strange noises or operate improperly, do not wait until the cord catches on fire. Repair or replace it immediately. Due to the improper wiring, again fire may take place. Outdated wiring or improperly installed fixture and electrical upgrade could increase your fire risk. So for the fire prevention technique, what you have to do? Qualified reputable electricians always follow the National Electrical Code. So if you are not confident, you can complete a rewiring job safely. Hire someone who can do this work properly as per the electrical norms. Now, use of correct equipment to prevent fire. One great way of preventing fire in the workplace is by placing the correct equipment in the building or the industry. You may want to ask the local fire department to visit your business during the remodeling process or to make sure the building is properly enhanced with fire prevention equipment or not. The following items should be placed inside or near the building. What are those items? First one is fire alarm system. Second one is fire doors and or shutter. Third one is fire hydrant that are operational. Next is automatic sprinkler system. Next is fire extinguisher mounted and easily accessible to all the employees. Now we are going to discuss working at height. So working at height means that an individual is working in a place that requires necessary precautions to prevent them from falling at distance, resulting in serious injury. Injuries from working at height is one of the most prominent cause of the major work related to injuries and fatalities. Falls from ladders, scaffolding and lifts onto debris can cause serious injury even when height is perceived to not to be dangerous. Employer need to ensure that they take all measures necessary to lower the risk of their worker falling from a height using preemptive hazard recognition to constant site assessment. Now there are different do's and don'ts when you are working at the height. So first we are going to discuss the do's of the working at height. So do as much work as you can while you are on the ground. Do make sure that employees can safely move to and from the area where they are working at height. Do ensure that equipment that you are using for the job is strong, stable and suitable enough to get the job done. Inspect and maintain them regularly. Do be careful when you are working near to the fragile surface. Do ensure that you are protected from the falling object. Do make preparation for emergency evacuation and rescue. Now we are going to discuss different don'ts when you are working at height. Don't overload the ladder that they are working on, which equipment or materials. Don't try to reach too far when you are on ladder or step ladder. Don't use ladder or step ladder to do work that entail heavy or strenuous tasks. Only use them to do work that are quick and light. Don't allow incompetent worker do any work at height. You have to take care that don't lean or place the ladder on or fragile upper surface. Don't stay quiet when you feel someone is compromising their own safety or safety of others. So these are the don't when you are working at heights. Now we are going to discuss permit to work. This permit to work is used to ensuring the safe and effective work management. So permit to work refers to the management system used to ensure that work is done safely and efficiently. These are used in hazardous industries and involve procedure to request, review, authorize documents, and most importantly, deconflict tasks to be carried out by the frontline workers. Permit to work is an essential part of the control of work, the integrated management of business critical maintenance processes. Control of work is made of permit to work, hazard identification and risk assessment, and isolation management. Permit to work is a core element of integrated safe system of work system, which along with risk assessment and isolation planning enable as low as reasonable practicable reduction of unsafe activity in non-tribal work environment. Permit to work adherence is essential in process safety management. Instructions or procedure are often adequate for most work activities, but some require extra care. A permit to work system is a formal system stating exactly what work is to be done, where and when. A responsible person should assess the work and check safety at each stage. The people doing a job sign the permit to show that they understand the risk and precautions necessary. Permits are effectively a means of communication between the site management, plant supervisor and operators and those who carry out the work. Example of high risk job where a written permit to work procedure may need to be used include hot work such as welding, vessel entry, cutting into pipe, carrying hazardous substances, diving the vicinity of the intake openings, and work that requires electrical or mechanical isolation. It is also a means of coordinating different work activities to avoid conflicts. A permit to work is not an replacement for robust risk assessment but can help provide context for the risk of work to be done. Common failure in control of work system are failure to follow the permit to work or isolation management procedure, risk assessment that are not suitable and sufficient to identify the risk, and the control, the measure and combination of the two. Work permit system is a technical measure document to prevent hazard and accident. A work permit system spells out nature of job, equipment involved, times limitations, locations and personnel involved. Permit to work is a written record document raised by the shift in charge, area in charge and authorized by the safety personnel, permitting the work in a specified time in a defined area. It ensures the responsibility of the individual for performing the work. This work permit will identify the hazard full to personal, equipment and property. Following aspects should be considered with respect to the permit to the work system. What are those aspects? These aspects are human factors, management of work permit system, skilled manpower, knowledge, wisdom and experience, competence, objective of work permit system, types of the work permit required, contents of the work permit. Now we are going to discuss earthing and current leakage. Electricity is carried by the conductor that are supported above the earth or inside the earth, but are electrically isolated by insulator, which prevent the electricity from the neutralizing itself as it would if it shorted to earth. However, there is some very small leakage across this insulator, especially aerial insulator during wet or humid condition. This is called earth leakage. We may sometimes hear the discharge from high voltage wire is foggy condition. An earth leakage circuit breaker is a device used in electrical installation that measures the amount of leakage to earth by comparing the electrical flow through the phase, or you can say live wire, and the neutral, or you can say return wire. If this differ by a significant amount, then it will assume there is a fault in the wiring and it will trip, cutting off electricity supply and possibly preventing the electrocution or fire. Leakage current is the current that flows through the protective ground conductor to the ground. In absence of the grounding connection, it is the current that could flow from any conductive part or the surface of non-conductive part to the ground. If a conductive path was available, there are always extraneous current flowing in the safety ground conductor. Electrical equipment commonly includes a grounding system to provide protection against shock hazard if there is an insulation failure. The grounding system usually consists of grounding conductor that bonds the equipment to the service ground. If there is catastrophic failure of the insulation between the hot line and touchable conductive part, the voltage is shunted to the ground. The resulting current flow will cause a fuse to blow or open a circuit breaker, preventing the shock hazard. Obviously, a possible shock hazard exists if the grounding connection is interrupted either intentionally or accidentally. The shock hazard may be greater than supposed because of the leakage current. Even if there is a no insulation failure, interruption of the leakage current flowing through the ground conductor could cause a shock hazard to someone touching the underground equipment and ground at the same time. The double insulation provided in non-grounded equipment provides protection by using two separate layers of insulation. The protection in this case ensured because both layers of insulation are unlikely to fail. However, the condition that produce leakage current are still present and must be considered. So there are two types of leakage current. One is AC leakage current and second is DC leakage current. So what is AC leakage current? AC leakage current caused by the parallel combination of the capacitance and the resistance between a voltage source and the grounded conductive parts of the equipment. Now we have to understand what is the DC leakage. DC leakage current usually applies only to end product equipment, not to power supplies. The leakage caused by the DC resistance usually is insignificant compared to the impedance of the various parallel capacitances. The capacitance may be intentional or unintentional. Some example of unintentional capacitances are spacing on printed wiring board, insulation between the semiconductor and grounded heatsink, and the primary to secondary capacitance of isolating transformer within the power supply. A meter specially designed for measuring leakage current is used. The current flowing in the ground conductor is measured by the connecting meter in series with the grounding connection. For information processing equipment, the ground connection is opened and current flowing to the neutral side of the power line is measured. For very low leakage current, the meter is replaced with a network consisting of either a resistor or resistor and capacitor combination. The voltage drop across the network is then measured using a sensitive AC voltmeter. Ungrounded or double insulated equipment is checked with the connecting the meter between the touchable conductive part and the ground. In case of the non-conductive housing, a copper foil of a specific size is placed on the housing and the current flowing from it to ground is measured. Now we are going to discuss working at high voltage and related hazard. Electricity is classified as high voltage if it exceeds 1000 volt AC or 1500 volt DC. Equipment and conductor that carry high voltage have specific safety requirement and procedure. In alternating current, the flow of electric charge periodically reverses the direction, whereas in direct current, the flow of electric charge is in one direction always. Usually high voltage means electrical energy that is high enough to harm living beings. Equipment and conductor that carry high voltage require special safety, precautions and procedure. In some industries, high voltage means voltage above definite threshold level. Here we can define the threshold voltage level on the basis of the IEC voltage rating. So high voltage can be defined if AC RMS voltage is more than 1000 voltage, and if DC voltage is more than 1500 voltage, then it will be called high voltage. And there are risks associated with the high voltages, electrical arcing. Now if we are defining the low voltage on the basis of the AC RMS voltage, so if AC RMS voltage is 50 to 1000 voltage, then it will be called low voltage. If DC voltage is between 120 voltage and 1500 voltage, then it will be called low voltage. And risk associated with the low voltage is what? Electrical shock. Now we can also define the extra low voltage. So if AC RMS voltage is less than 50 voltage, then it will be called extra low voltage. If DC voltage is less than 120 volt, then it will be called extra low voltage, and there is a very low risk associated with the extra low voltage. The numerical definition of high voltage depends on the particular cases. Two factors considered in classifying a voltage as high voltage. First is possibility of causing a spark in air, and second the danger of the electric shock by the contact or proximity. The definition may refer to the voltage between any conductor and ground or between two conductor of system. In electrical power transmission engineering, high voltage means approximately 35,000 voltage. This is the classification based on the design of the apparatus and insulation. Now there are different causes of the injury due to the electric current. There are primarily four types of injuries that can occur due to the electric current. These are the electrocution. Electrocution occurs when electric current passes through the body. If current flows through a vital organ of any living bodies, it is almost always fatal. Contact with a low current can cause fibrillation within the heart that can be reversed. However, contact with the high current can cause significant burns and damage to the cells. Second is electric shock. Electric shock can cause significant damage to the nervous system. When any individual comes into the direct contact with the current, it can cause the injury and severe burn or long-term chronic pain. Third one is electric burn. Electric burn are very difficult to treat and can cause permanent scarring to an individual. The initial contact with an electrical current can cause burns to appear on the skin. These burns can range from minor to severe. Electrical burn cause chronic pain, headache, memory loss, dizziness or irregular heartbeat. Next is falls. Direct contact with high voltage electrical current can cause loss of muscles control or loss of consciousness. This can cause an individual to fall off from tower or a ladder. These falls can create serious injuries that may be life-threatening. Staying safe while working around electricity. Staying safe when working on electrical equipment starts with staying concentrated on your work. focused on your surrounding. Staying alert is very important while working around electricity, which can save your life and the lives of the co-workers. These include carefully inspecting equipment before working on it and always following the prescribed safety protocols while you are on the location. It is also very important to routinely check your safety equipment like the soles of your rubber shoes, leather gloves when working on electrical equipment and transmission line. Before starting to work on electricity, remember to check yourself properly to make sure you have removed all jewelries, watches, cell phone, etc. This can significantly reduce your risk of injury. You should also ensure that power has been shut off before work on any electrical line or equipment. Now we are going to discuss precautions need to be taken when working near high voltage lines. So first precautions is keep safe distance from high voltage lines, approximate 6 to 20 feet away depending on the strength of the line voltage. Second one is use non-conductive wood or fiberglass ladder. Third is ensuring the high voltage line has been de-energized before starting work in the vicinity of high voltage line. Wear personal protective equipment such as rubber insulating gloves and insulating sleeves and industrial protective helmet. Educate worker on safety procedure and requirement. Some medical device that is pacemaker can be affected by electromagnetic field produced around high voltage. If you have one of these devices, you should inform to your project dealing officer. Always discharge the high voltage from component or terminal by using a safety probe. Do not hold the test probe when circuit over 300 volt are tested. It is very important that you only work with any sort of electricity if you have completed an assessed training course run by an accredited training organization. Additional training would be required to work with high voltage electricity. Now we are also going to discuss what is the responsibility of the employer. Employer must do everything to ensure the safety of the employees working with the electricity. Only trained and competent employees should be allowed to work on the electrical equipment, especially on high voltage. All electrical equipment should be suitable for the environment in which it is used. In case of damp or wet environment, electrical equipment should be suitably insulated to prevent electrocution. Be careful around the output circuit even when input power is off, because parallel power sources and energy storage device can still be dangerous. Inspect the power supply and check all protective devices before working on high voltage. Label all equipment to identify power sources. Label input power sources to identify connected power supply load. Emergency shutdown instruction and phone number should be attached to the equipment that is remotely controlled and unattended while energized. Before entering a power supply or associated equipment enclosure to work on hazardous energy sources, ensure following procedure. First, de-energize the equipment. Second, open and lock out the main input power circuit breaker. Third, check for auxiliary power circuit that could still the energize. Inspect automatic sorting devices for the proper operation. Sort the power supply with grounding hooks. Turn off the power before connecting alligator clips to any circuit. To test a hot line, never use your fingers. Use approved voltmeter or other voltage indicating devices. So dear learner, in today's session we discussed the purpose of the personal protective equipment. Then we also discussed what is the purpose of grounding. Circuit protection device has already been discussed. That is circuit protection device that is limit or stop the flow of current automatically in the event of ground fault, overload or short circuit in the wiring system. Then we have also discussed earth leakage circuit breaker. Leakage current was also discussed. which is the current that flows through the protective ground conductor to the ground. We have also discussed permit to work, that refers to the management system used to ensure the work is done safely and efficiently. And we have also discussed what is the purpose of the work permit. Work permit are effectively a means of communicating between the site management, plant supervisor and operator and those who carry out the work. Then we discussed what is electrocution. Then we have also discussed what is electrical shock. So electrical shock is what? Electrical shock can cause significant damage to the nervous system when an individual comes into the contact with the current, whether directly or indirectly they can become fused to the point of contact. Hope you are able to grasp all the topics in good manner. In the next session we would talk about some more concept like basic of the electrical system, like what is a conductor, what is an insulator. Then we will also discuss type of the current and voltage like AC current, DC current. Then we will also discuss different electrical components like resistance, inductance, capacitance, coil, what is the purpose of the fuse, and we will also discuss principle and procedure for the safety of the electrical equipment. Thank you very much.